Countdown.
Oh wow, that's fancy.
Yeah. Okay. So. Okay, so now we should be on the YouTube. Let me actually check.
QuickTime just ate my ears, by the way. Like, try turning it on and then it just crackles. So
Oh,
I'm not sure how well I can support this local audio recording situation because I'm not equipped.
wait, so you open QuickTime and then you go to new audio recording and it just
And it goes and yeah.
Oh, is your the volume on it, if it's like up, it'll like feedback loop if you're not careful. So if you turn that all the way down, but
Are you able to? Do you have multiple mics? Are you able to select?
I
which one you're
have
picking up?
a physically external mic hiding down here, and then the AirPods that sound is going in through.
okay. Well,
But yeah, I don't know. I mean, do we need like quadruple redundancy here? Or
no,
can we
it'll,
survive without?
it's probably okay. Yeah, it says you're uploading, so we're probably good to go. All right, and then let me just get the stock so I can see it. That's not the zoom I want. Whatever, I'll do it this way. All right, so time to play the intro. I hope this isn't too loud.
Is it playing? We don't hear it. I think only you can hear it, Chris.
Hmm.
I mean, either that or he's just dancing to his own sounds.
Oh wait, you can't hear that?
Nope.
No, we can't.
Oh my God, Riverside. All right, well they'll just add it in post then.
Yeah. Yeah, that's usually what they do, anyways. Yeah.
Yeah.
Oh well. Okay, so let's get this started. Welcome to Go Time. This week we are doing part 2 of our mini series on maintenance and the importance of maintenance in our industry. As I said in the first episode in this series, hold on a sec. Hold on. Okay, I figured out what was wrong with that. Okay, I'm gonna start again. The glory of post-production. Also, hi people on YouTube. You're seeing how podcasts actually get made.
Right.
All right, I'm gonna start again. Okay. Welcome to Go Time. This week we're going to be doing part 2 of our multi-part mini-series on maintenance and the importance of maintaining our software. As I said in the first episode in this series, we talk a lot in this industry about innovation, about greenfield projects, about prototyping and hackathons, but rarely do we talk about the longer side of things when it comes to software, the maintenance and the long-term prospects of it. This week's episode is going to be focused on building actually maintainable software and what goes into that. And this week, I am joined by Sam Boyer. Hi, Sam. How are you doing?
I'm lovely. How are you?
Great. And to give you a little introduction of Sam, Sam is a principal engineer at Grafana Labs, where he just switched teams to be responsible for Grafana's Go backend. The team is nominally in charge of around 250,000 lines of code. That's a huge amount of code right there. Sam thinks a lot about code evolution and quality, usually under the umbrella of package management, an area he's been working in for the better part of a decade, as I'm sure many of our listeners are well aware of. And I'm also joined today by Ian Lopshire. How are you today, Ian?
I'm doing great.
Yeah, and to give you guys an introduction of Ian, Ian is a senior engineer at TimeHop, where he's responsible for keeping TimeHop's Go backend in working order. TimeHop integrates with multiple social media platforms to surface millions of user photos and posts each day. And,
Yes.
go ahead.
It's like your own little day in history.
Yeah. Yeah, I remember Time Hop from back in the day, and you guys are still going strong. It seems.
We are.
And I'm also joined by my fellow host Johnny Bursico. How are you doing today, Johnny?
Not too bad, not too bad. I bring hot takes, so
Yeah, I'm ready for some good Johnny hot takes. And not just...
I thought of a couple unpopular opinions, but if you have extras to spare, I mean, maybe I'll just lean on you for those, Johnny.
plenty to go around.
Excellent.
There's going to be a lot of unpopular opinions in this episode, I feel. All right. So with that, let's get into talking about maintenance and how to build maintainable software. And I want to start with thinking about, how do we build actually maintainable code for new code bases, right? Because there's, some maintenance you do for old code bases, but then you have, new code bases. And we always start with these great ideas when we make like a new one, but rarely are we thinking about, what's it like when that, when that code base actually goes to production? What are the steps to get toward it? So I guess we can let's start with you, Johnny. What are the things that we should be thinking about when we, build a new code base and we're aiming to get it to production from more of like, I guess, a maintenance standpoint?
Well, that's the thing. You don't know if whatever it is that you're working on is going to be around for the long haul, right? So we have this assumption that all the pieces of code that we write is worth getting all production ready and everything else like all the time, and that's really not true. So as you say, like a lot of times you start out with basically doing some prototyping, some R&D. It is an unfortunate fact that a lot of times, right, due to business pressures or whatever timelines, sometimes most of the time manufactured time frames for things, that the stuff you have ends up going to production, and you're like, oh man, like we really didn't do all the due diligence necessary, or all the prep, all the operationalization, all the production readiness stuff that should have gone into this, right? It was just a prototype. Now management wants it and to be deployed and whatever it is, so you're playing catch up now, right? So but in the ideal scenario, right, you figure out basically what is it that I'm building, that I'm tasked with building, right? And making sure that everybody understands this is the scope of this work. This is really, it's meant to show you something, right? To maybe you're trying to determine product market fit. Is this thing real? Does it have legs? Whatever the case may be, but with the intention of actually making it ready for production. These are very separate steps, right? When you're exploring and when you're making something production ready, these are very, very different things, right? Again, it's unfortunate that a lot of times the toy ends up going to production. But yeah, you kind of have to basically ask yourself, start out by saying, hey, do I have an agreement with whoever's asked me to build this piece of software? Do I have an agreement on where this is actually needs to go, right? Is it a toy that I throw away at the end, or is this it, right? Because there's going to be very different approaches to these things.
Yeah, I think, and that gives me like a lot to think about, man. You just started.
I told you, man. I bring the heat. I told you. I mean, I've got opinions about this stuff.
Okay,
well, that's
that's
the start of the diverging path, though, right? Like it's we can all imagine the best of intentions for making things maintainable over the long term, but those pressures exist at all times. And a lot of the reason that, and certainly I don't disagree at all. That initial stage, you don't know if the thing that you're making is trash or not. And the only way to figure out if it's trash is get it to the point where it actually runs and see if it's not trash. And the faster you get to that point, the faster you figure out whether it's actually worth putting the effort in. But so my only point is to say, no, I agree. But I think that the point there is that the diverging tensions between like a sort of high quality or maintainable code base, and I have a thing to like talk about whether we think those are different things later. But I think those paths start diverging right from the beginning. Like, is it high quality maintainable code base, or does it do the job? And resources are finite, time is finite, and I think it's a good point. Those pressures are there right from the beginning.
Ian, do you have anything you want to say on this topic?
Yeah, it's kind of along those same lines. I think a important piece at the beginning there is, does this piece of software is this something that we can actually solve with software? I've been in the situation where you got to build a piece of software to automate something or do something, and it turns out the edge cases and the error cases are just too numerous, and it's more of a headache to fix those than it is to actually just manually do the work. So I think at the very beginning, you got to kind of start with a actual problem. Yeah.
Okay, but let's say that we've already figured out that, you know, we have some code, right? We wrote some code, we prototyped, we're like, okay, this idea is solid and we can go forward with it. Is that, I guess, like, at that point, what should we be doing? What should we be thinking about to, like, make that code base more maintainable? Or are we saying that perhaps we shouldn't be focused on maintenance in these earlier times, and we should be trying to focus on it later? I guess, like, how do we start to strike that balance there? Because I know, like, a lot of us, you know, go into companies and, you know, whether it's moving from monolith to microservices or just, you know, you have microservices and you're starting a new one. And there's always, you know, as Johnny and Sammy said, there's this hope. There's just, like, green field, this whole new path you can go. And there's all these different directions. And there always is that trade-off of time, as you also brought up, and constraints. But at some point, we have to say, you know, there's obviously a trade-off at some point where if you don't maintain, then you're going to have to wind up throwing this whole thing out. And then all of that time you put into it is now gone. And you have to, you know, start all over again and pay those costs all over again. So is there a point, or is there, I guess, some signal or some way of knowing at what point you should start focusing a little bit more on maintenance and stop trying to maybe optimize for those, you know, time or whatever it is, you know, product features, whatnot?
I think we need a definition from what maintainable is at that stage, right? Because I think if I'm speaking from a developer, like the person writing the code standpoint, my idea of maintenance is perhaps different from, say, an operator's viewpoint of maintenance, right? And again, the sort of, there's a subtle difference. Well, in a lot of cases, not so subtle, between sort of operating, right, a piece of software that you and other teammates have written, right, and making that easy to operate, easy to maintain from an operational standpoint. And then there's the aspect of, okay, I'm working in a problem domain. I don't know everything there is to know. I don't know what business is going to throw at me next. I need to structure my code, right, and perhaps follow some best practices and design patterns, whatever the case may be, right, to be able to extend the software easily, right? So different kind of views on maintenance and maintainability of long term. And interestingly enough, different companies, depending at their stage of sort of their sort of technology sort of maturity, right, or engineering discipline and maturity, right, they're going to be on different sort of positions on sort of spectrum, right? So I think really you can't look at sort of maintainability in a vacuum on its own. You kind of have to say, well, for us, what does maintainability mean, right? And that's going to vary from team to team.
I feel like Sam has something he wants to say about that.
I'm percolating. I'm not sure I can. Well, the problem is actually, I think I hung on to something you said earlier there, Johnny, about the difference between operating and maintaining, right? Certainly there are differences, but to my mind, I don't know. I've had a few thoughts swirling around in my head about what it means to do maintenance, because I do agree, like, we need a definition for what that actually is, right? My sense is that there are two fundamental ways in which we can think about maintenance. One is the fixing bugs, and the other is adding features. And those two things have tensions involved, right? But what I was thinking about when you were talking was how I think there actually is a really important commonality between operational characteristics and like development time characteristics. And to me, that's failure locality. It's the idea that I want the computers to tell me as closely as possible how the thing is failing so that I can fix it. And that is true whether I am writing tests, because to me, a good test is something where when it fails, I know right where to look, I know right what to fix. And that's not something that I need to rebuild a ton of context for, or somebody else can come in and do, right? Similarly, when something is failing in one of its operational characteristics, I want to know as closely as possible, like where to look, where to go. So I think there's a common principle there in terms of the way that we should be approaching making, and that's mostly on the bug fixing side, right? Mostly, I think, on the bug fixing side. But maybe where the paths meet in the woods of the two approaches, or of the bug fixing and then the feature adding, is the extent to which, you know, your tests and your telemetry and whatever systems you have set up for consuming your operational information are able to tell you when the thing that you were adding over here broke some stuff over there, right? And quickly guides you to the same thing. Because I mean, ultimately, what we're talking about here is like, does the software continue to be correct or not, and how can you tell? Yeah. So, but I apologize though, because like I said, that it kind of took off like a thing you said at the beginning, and I feel like I missed the tail end of it, which is why I was thinking about biting my tongue. But then Chris called on me, so I'm sorry.
Ian?
He's got some thoughts too. He looks deep in thought.
Yeah, so this idea of like locality, I think is important for maintainability as well. Like I feel like if we minimize the amount of like unrelated changes that have to happen to make a change, a desirable change that is maintainable, right?
So perhaps because maintainability, right, has all these facets, right? Perhaps we can sort of come at it from the other way around. What would we call unmaintainable software, right? How do we define that? I think that's something we perhaps all might agree on, as these are the sets of things, right, in practice that make a piece of software unmaintainable. And I'm sure over the course of our individual careers, we've probably seen a few, right? I
mean, you could start with anything you can lint for, right? Like, especially in Go, where there isn't a lot of disagreement about like what should go into linters. That's a lot more common in other languages. But I mean, if you can lint for it, then yeah, like, you know, put basic docs on your functions and your exported members. You know, maybe don't have insanely short variable names for literally everything that you do. There's a number of sort of, there's the minimum bar, right? And I feel like we can almost just, you know, put a check mark on the list and say, okay, if you can lint for it, like maybe just, you know, do that from the start. And actually I would loop back to the early question, right? Even in a new code base, like throw the linters in as soon as you can. Maybe you can ignore and just write some dumb, like, you know, one-liners for your function docs, right? But like, don't make things harder for yourself. Just start from that and get yourself a nice little like foundational baseline going of the basics. But I used words to identify the easy parts, so somebody else can talk about the other things that might be harder to agree on about what makes unmaintainable code. Because I think it's a great question. I think coming at this from a negative angle is a good way to do this.
Ian, do you have ideas on what makes unmaintainable code?
I mean, I do. I think like fundamentally untestable code is unmaintainable. If you can't know if it's correct, you can't make changes to it. So some things that make things fundamentally untestable, like heavy use of globals, that sort of thing, I think is probably the biggest thing that sticks out to me.
I feel like there's something you said earlier, Ian, that I would classify as making software unmaintainable, which is like if we don't know what we're building, I feel like that fundamentally makes it very difficult for us to write, you know, software that we can maintain. I feel like if you don't know the scope, right? If you haven't sat down and written a scope and written a design, then the resulting software, it might do what you as an individual thought the software should do, but that might be slightly different from what other individuals thought the software would do. And I think that's one of those like longer term maintainability problems, because you know, if people have different concepts of what a specific code base or a specific package or a specific function even is supposed to be doing, then when multiple people work on it over time, it kind of atrophies and it kind of falls apart. And I think we've all seen these functions that live in code bases that have just been hijacked to do something completely different from what the original author intended. And you're like, how did that happen? And I feel like that's upstream a scoping problem. That's upstream, like we didn't properly define what this thing was supposed to do. And I feel like that fits in that category of like gnarly things that Sam was just like, you did the easy stuff. This is a harder.
Well, no, I agree, but I want to ask a maybe annoying question there, which is, so Ian said test code that's fundamentally untestable, right?
Mm-hmm.
How is code that's untestable different from code where the intent is not clear?
It's not. If behavior is not defined, like.
What if you're testing the wrong thing? Right? Like you have tests, right? You test that
right.
The assumptions you made, though wrong, pass your tests.
and I feel like there's that cyclical testing that people tend to get into with unit testing as well, where they test at like the wrong level. And it's like, well, that thing is tested. You've tested it. It does the thing that you thought it was supposed to do, but like the thing you thought you were supposed to do is not the thing that you actually wanted to do. And I think that's the difference there as well. Like you as an individual, if you write the function and then you write the test, then obviously, I mean, I hope that the test that you wrote have now, confirmed that function does what you want. But if, you, Sam, and I have two completely different ideas about what this function is supposed to be doing, we can both write tests and those tests can both pass, but that doesn't solve that, initial problem of like scoping. Like this function itself is still not well defined. So I do think that they are divergent paths, or maybe like one encapsulates the other, right? Like if you have untestable code, then you've most definitely probably scoped it wrong. But scoping it wrong doesn't necessarily mean that it's untestable.
Scoping it wrong doesn't necessarily mean that it's untestable. Yeah, no, that certainly is the case. I agree. I do think there's a difference between these things, but I think that it's worth asking that question because having a clear sense of like what it is that this code's supposed to do, the boundaries within which it's supposed to exist, is astonishingly important to like actually trying to maintain a code, especially as a code base gets larger. Should this function go in this package? Should it be a new package? Why? Like, what's the logic by which we are grouping these things? Is there some like broader theme that we can use to decide that this is how we actually organize our code? This is where we ought to look for something like that. These, as your code base grows larger, and you can't just kind of, oomph your way through, like finding things inside of it, like having larger patterns for why code gets grouped in different ways, having larger structural patterns, whether those are, something like formally defined by interface contracts or less formally defined, formally defined by like type checkable interface contracts, less formally defined in terms of like naming convention patterns, or really informally defined, but still very important in terms of like general patterns and responsibilities. And like, we're going to put a collection of packages under a single tree that are service-y shaped or something like that, right? As your code base gets larger, and take note for that intro bit where I'm currently thinking about and mostly learning a 250,000 line code base at the moment, having patterns and structures like this, I think do an enormous amount to orienting the maintainer, who inevitably, given a large enough code base, you just have to assume that every maintainer is basically naive at some level about what's in some code. They do a lot to orient the user, the maintainer, towards intent, which is the first step towards being able to figure out what should be tested, which is the next step on the path to figuring out whether the thing does what it's supposed to do after, in the first place. So, yeah.
I feel like sort of reaching, so you don't wake up one day and you have an unmaintainable code base, right?
No.
You're going with the same like terminology that we established. So I think you gradually get there. And even if you're, so we've already sort of created, or at least identified the nuance between correct code and testable code. The two are not necessarily the same thing, right? But I think, to me, you start to gradually get towards an unmaintainable code as you start to let your technical debt, which is, that's not a bad word, that's not a dirty set of words, right? Technical debt is absolutely, I think that's necessary, right? And when you're evolving software, as long as you,
if you don't have debt, you haven't done anything great.
Exactly.
Yeah.
Literally, you need technical debt is part of the currency, right, that you have, right, to trade for things, basically to pay an upfront cost for a certain
Yeah.
feature, right, and then to come back and actually like fix the things that really make it maintainable in the long term, right? So when you don't address your technical debt, you start to creep towards that unmaintainability, where to the point where it's like, oh man, like I'm looking at a code base which has been around for a couple of years, and there's 3 different ways to do the same thing with a slightly different parameterization. This one accepts like an empty interface here because somebody wanted to make it super flexible, but they didn't understand enough about the problem domain. Now you end up having to create another one with more specific. You can see those like sprinkles of just different people trying to solve the same problem in different ways, and not basically saying, okay, we've done enough sort of damage, right? We have an understanding of what it is that this thing's supposed to do now. Can we just take a minute, take a step back, take all the different ways we do the same thing, refactor, right, for maintainability, right? As opposed to somebody come in, next week and says, oh, now I need a slightly different version of this thing. Now you have 4 ways of doing the same thing, right? So that you start that march towards increasingly unmaintainable software, right? But no, is any software truly unmaintainable? That would mean that you can never do anything else to it, unless you basically on a code freeze. That's it. It's done. You're never touching it again. Like, as long as software is delivering value for the business, you have to maintain it, right? So, but if you don't address, the things that, if you don't do the things you're supposed to be doing, right, towards making something maintainable for the long term, you're gonna increasingly creep towards that increasingly unmaintainable state.
Have you guys heard the rant about the word performant and how it's a made-up word that doesn't mean anything? Like, is the software performant?
What does that
mean? How fast is performant? So I ask it here because I think maintainable is the same kind of problem, right?
Mm-hmm.
How at what point, the point is we're on a sliding scale here, like, and whether or not you would call something maintainable or unmaintainable, I mean, realistically, that's a question of how bad your day has been. But if you're being a little bit more high-minded, it's like, what is the appetite of the organization that I am in for allocating a bunch of time for being able to make changes to this thing? Mm-hmm. So it is fundamentally contextual to like the environment that you are operating in the same way that, like, is the code performant is actually a question about what the appetite of the organization is for, like, accepting latency, whatever, along this particular path. There's no objective standard here for it, which is why, as you say, Johnny, it's this risk of the creep towards you can continually add things that might make it more unmaintainable, but maybe would never necessarily reach there, or or exogenous factors that might change, like how many things are relying on that code that will suddenly have it be in an unmaintainable state, whereas before it seemed fine.
Mm-hmm. And I think you have a good call out there, because I think the business is also on the hook for ensuring that there is enough space, time, resources for keeping the software maintainable. Because if you don't, and as I'm sure we've all either experienced or heard, like if you're never making room for improving your code base, not adding new features, not fixing bugs alone, but really improving the code base to make it easier to work in, eventually your shipment of features is going to come to a crawl, and everybody's like scratching their heads wondering, why does it take like 3-4 sprints of 2 weeks a pop to add just this one feature, right? Everybody ends up scratching their heads asking that same question, and the answer is always the same thing. Well, we keep wanting to go back and fix these other things, but we never get the time. There's always a demand for ship this next thing. This is important, about this, that, whatever it is, right? Basically, the business, right, is not caring about what it takes, what behind the scenes, the things that they can't see, right? We're the engineers. We need to make the case for the time, the resources, the space, right, to improve the code base. If we don't do that, the business is not going to do that for us automatically. They're going to be, to them, it's like, hey, can I get this? And you deliver it. Okay, here's what's next. Can I get this? Because they have pressures from customers, from stakeholders, right? That basically, as long as you keep giving them stuff, they're going to keep asking for more stuff, right? If you don't fight for the space and time, right, to make your code base maintainable, right, easier to keep adding things to, that's how you get in trouble.
We had a discussion recently. We have a thing, Grafana, called Gardening Week, which I had not heard referred to this way before. This is my first time hearing the term. But after we do a release, we have like a gardening week basically, and there was a discussion amongst the discussion about like, well, should we have a gardening week? Like, is it a bad thing that we have gardening week? Wouldn't it be great if we didn't like need to have a gardening week? And my sense is that there are three. I'm going to try to pre-count the number of universes and then get it wrong. So I'm going to say there's 3 universes and then get it wrong. There's the universe where you have a gardening week. Sorry, you don't have a gardening week, but you need one. You don't have a gardening week and you don't need one. And you have a gardening week and you need one. Yeah. I don't think the like have it and not need it is a super realistic one, but there you go. There's my missed count. There's 3, but maybe there's 4. Anyway, point is like, I had this initial reaction to seeing the existence of gardening week and seeing, oh, like, come on, can't we kind of do that as we go along? And then I realized, no, like actually I would so much rather be in a world where there is 2 words, gardening week, that has an understood meaning and an understood reason why it's valuable to the business and why it's valuable to the people involved. And that we have that time and that space allocated in a sort of structured way, because it is way better than being in the world where you need a gardening week and don't have it. I would love to be in a world where we don't need one at all. I'm not sure that's ever realistic. But having phrases like this, I think, help to maybe make it less of a fight all the time to have to advocate for this. But if you don't have one and you need one, you need to advocate, because otherwise it's not you're just gonna keep on trying to push that Sisyphean rock up the hill and struggling, and the business will only see things slowing down and not really understand why.
And I guess I have a sort of question off of that, but I want to preface it with something. Like the code bases I've worked on that have been unmaintainable, it feels like unmaintainable, where it's like this thing should take a week and instead it's taking 4 months to do. This is miserable. I hate everything. Right? Whenever I've wound up in one of those situations, it's always like it's not like one big thing that's the problem. It's always like thousands of little tiny things, and then you look at those in isolation and everybody's like, well, that's a little thing, so is it really worth it to go and fix it? There's all this other stuff we need to do. Like, it's always like, we know that it's death by 1,000 paper cuts, but we never want to like stop any one of those paper cuts from happening. So the question I have based on that is like, is gardening week enough, or should we actually be pushing further and saying, we want like a gardening team? Because I think there's this, myth that exists in our industry that like people wouldn't like working on said team. It'd be like this miserable thing where like, oh, well, that's the team of people that doesn't get to do the fun stuff of building features and building new products and doing all of that. But I think, and I have some friends that are like this, that are like, no, just give them code base. Let them go and just like clean up some certain parts of code bases.
Scratch that itch.
And that's just like, that's what they want to do. Yeah, like the garbage men. Like every city, like imagine what our cities would be like if there were no garbage people, right? Not garbage people, but like trash collectors. That's a better. I mean, it'd be good to have.
I didn't hear it till you said
it. I mean, it would be a wonderful world if we didn't have garbage people.
If we didn't. Imagine a world if we didn't have trash collectors, right? Like our streets would be disgusting. Our cities would be awful. But like, there's no one there that's saying like, and there's some people that are trash collectors and that they love their life. Like they are so happy with like what their job is and how they live their life. And I think there's like a significant portion of software engineers that want to do that sort of thing, that are like, just give me like, let me like take this part of the code base that has that function that has like 15 parameters, and let's just like, I'm going to think about it and refactor it and just make it better. So the next time someone comes through, it's like not as bad to be in that space. But I'm wondering if that's something that we should be pushing for, or if there's like another version of that, or is it just like, well, let's just start with gardening weeks, and then we can figure out what we should be doing after we have this at like, most of the organizations.
I don't think that's something that needs to be option personally, right? If I'm running a team, if I'm an engineering manager, like if unless the team is gelling so well that I don't need to formalize the process, right? I'm just making it a formalized process, right? I'm just making it just like, going on call. There's a rotation schedule. You go in that squad, other people call it health squad, right? You can call it gardeners if you want, right? So, but you do your time in there, right? And I say that I don't want it to sound like it's a punishment or a chore. I think every engineer needs to understand what it's like to work on greenfield, projects, and they also need to understand how you maintain existing software that's been around for a while, that is making money for the business and paying your salary, right? You need to understand how that software works, and because when we need to change it, maintain it, right? Add features, fix security holes, or whatever it is, right? Everybody should be somewhat well versed, right? In that software. And obviously, different people, depending on tenure and seniority, whatever, they're going to have a much better time at sort of holding the whole problem domain in their heads, depending on how large your code base is and all these other factors. But at least everybody's working towards a shared common understanding, right, of the software, so that we can all keep this thing alive that's paying our salaries, right? So I think this is something that every engineer, right, should feel responsible for, basically contributing to the health, right, of a piece of code base, or however many you have in case of microservices or whatever.
I would question, though, if that's actually a good idea. Because here's where I'm coming. Like, I always pull analogies from like other things. I gave a talk at GopherCon where I basically talked about like how we're similar to the publishing industry. And when I hear like everybody needs to do like a rotation on this team to help clean up the code base, I hear like everybody needs to become a copy editor. And that I don't like that idea, right? I don't think that this is, I feel like this is like a higher form of engineering in a way than even just like product or feature engineering, right? I feel like feature or product engineering, that's like, here's the requirements. Well, it's being done well. It's like, here's the requirements, here's the scope, go make a design. Like it feels like this more structured thing. Whereas when you're trying to like do gardening or doing maintenance of a code base, I know that's still kind of a nebulous word right now, but when we're trying to do this, it's like trying to like, I guess, pull out value when you don't necessarily have that level of structure, especially within organizations, to make that happen. And I think the thing I worry about is like making bad trade-offs when it comes to trying to garden your code bases, right? Because just like we have to make, trade-offs when it comes to product features, we have to make trade-offs when it comes to gardening, right? There's 1,000 paper cuts that are happening here. We have to decide, which ones are at a part of your body that's just annoying and which ones are like, slicing an artery that is going to make you bleed out. And I feel like that's like
Chris. Your analogies, my friend.
These analogies are escalating, right? Like
up and away. But I feel like that's like a very difficult thing to figure out and to determine. And I feel like, just like there are people that are really good at like that prototyping, that hackathon style engineering, I feel like there's, people that are really good at this more maintenance mindset engineering. And just like I don't want to put maintenance people into hackathon style stuff because they burn out, they are miserable. I don't want to take people that would rather just be doing product features, or really rather be like, give me a ticket, I'll do that ticket, and then I move on, in a situation where now it's just like, here's a code base, go make it better, or go figure out the things that we need to do to make it better. So yeah, I think that's where I fall on that.
So I disagree with you on that. And because
disagreement.
Nice.
So this idea of like greenfield development, right? Like I think in a lot of ways it's an easier process. You're starting from new. You don't have a lot of things to consider, but you can only do it well if you have had the experience of having to go back and change things. So if all you do is build greenfield stuff, you're gonna leave a trail of debt behind you and never realize it. So if you have this distinction between a maintenance engineer and a greenfield engineer, I think you're gonna kind of end up with bad software.
And it's not necessarily saying that you have to be one or the other. It's more so saying that like we shouldn't make everybody like that's why I don't like it being a rotation, right? That's the thing I was more objecting to than anything else. It's like if people don't want to do this, that seems like an option that we can have in the same way that I think if people don't want to do product engineering, for example, like we're not like every engineer that works at a company must do product engineering. So I don't think that, you know, every engineer should have to do maintenance work. I think they should have to be aware of the maintenance work that goes on, right? We can't just like in observability, we can't just like, or with SREs, we can't just be like, the SREs will just take care of all of our reliability things. Like the engineers still have to care about this. But I think it's important to make the distinction of like who winds up working on this like the most and who develops like the ethos of it, right? So yeah, I mean, but I don't disagree with you either. So I think it is important to get people, you know, seeing the repercussions of what they build, right? We can't have a world where there are just like, I mean, that's kind of the world we live in right now, where there's just a bunch of people running around creating stuff, and then they're never around to pay for, you know, the repercussions of it, whether that's because, you know, it's kind of built into the organization or because, you know, it's a startup or whatever. And oh, well, we built this thing and now we've made an exit and now the next group of people can deal with all of our terrible decisions. You know, whatever form it takes of like cut and run, we don't want people to be doing that sort of thing. So I think it is important for people to understand maintenance, which is also why I guess I'm trying to like raise maintenance engineering to a higher level, right? It's like, you know, maintenance engineering in some ways probably should be above product engineering because you can't do product engineering without maintenance engineering, but you can definitely do maintenance engineering without product engineering because there's some code bases that have been around for decades that's just like, no, your job is to keep this going. We're not adding features to it. We're not doing anything new with it, but we have to keep this thing going.
I don't know. I would point back to, at least on the maintenance engineering is a higher form than product engineering. I'm not sure I can compare them. I would go back to Johnny's earlier point about technical debt and you borrow money to start a company. You take on debt for a good reason. And it's because you're trying to make something on, you know, the outside.
But I would say the debt you have to take on needs to be good debt, right? There's good debt and there's bad debt. And the people that are going to...
We can push the analogy too far.
but I do feel like this does come up in our code bases, though, because there's some code bases where like this technical debt, like this is acceptable for the trade-off we got. And there's other technical debt you're like, why? Like this was not debt we needed to take on, or this was debt we were never going to be able to pay down. Like I think that's worthy of like, you know, making sure we understand the debt that we're taking on, which I feel like is what maintenance engineers would understand a little bit better than people that aren't as focused on like what the repercussions of different types of technical debt we might take on.
So this feels like a good moment to stick in the question that I alluded to earlier, which is there a difference between maintainable code and good code in the way that we are talking about it?
Good doesn't tell me anything, though. I mean, I can show you. I can show you very good code that is obfuscated code, and you know it's designed to be short and terse, and it's good by that definition, right? So I always feel like we have to sort of provide the criteria, right? For
sure. Well, no, but that's why I'm asking the question, because I think it is easy for us to slide into it. Here, let me revise that. When I was thinking about maintainable code, I found myself sliding into thinking about good code. Mm-hmm. And the distinction between these, I think it's interesting where it is or isn't different. Like one thing that jumps out to me clearly is how I have internalized that belief that the best code is code that is easy to delete. That is the best code. It's not easy to extend. It's not super abstract and great. Nope. You can delete that shit. That's what makes it great. But the point there being, certainly, I agree. Like I do have some of my own internal definitions of good that I think have started to skew towards maintenance. But I asked the question here because if we're having a discussion about like what is the relative value of maintenance versus like pushing forward, right? Then it seems like part of the thing that we're asking is what our values are in terms of what actually makes code good versus not. So I asked the question kind of to put a spotlight on I guess another definitional issue that seems to be at play behind some of
I feel
this.
like
Go
they're
ahead.
different because I feel like there's code that I've seen and code that I've dealt with where I'm like, this is not good for whatever reason. Maybe it's like a Go code base that's written in, Guava, right? It's Java, but just happens to have Go syntax. And it's like,
Wait,
gross.
that's a thing?
Yeah.
Wow, you never come across
You've never come across
an
some-
iterable
Some factory in
Oh,
your Go code.
okay,
and
wait. I thought this is like an actual thing. Like,
Oh,
like
no.
Like a Java person wrote Go. Like I was about to like Google like Guava Go.
No.
Something. Yeah. Okay. All
Oh,
right.
you probably heard of Gooby as well and Gaitan and
Okay. Yes. We're back in a domain that I'm familiar with and slightly less terrifying. Bye.
So I've worked at some of these code bases before where I'm like, this is bad and this is gross and I do not like this and it makes me as a Gopher very mad that someone has done this. But I wouldn't say that those code bases were unmaintainable or like weren't maintainable. It's like, this is like, you're using interfaces everywhere. I hate you for it, but like there's a logic to them. They're arranged in a way that makes sense. And you can see like, okay, this is where we would add things. If we want to get rid of this, is where we would delete that, right? So for that reason, it seems like, yeah, we can have bad code that is still maintainable code. So I do think they are separate things. I do think in that case, like, the reason we're saying it's bad code is because you're writing it in a language, but not embracing the language you're writing it in. And I think, to your point, you could say good has to encapsulate both writing the language for the language and also making it maintainable, in which case then, you can't you can definitionally make it so that yes, good code and maintainable code are the same thing, but I don't think you necessarily have to do that. I think they can be distinct.
So, I mean, under that, never mind. It's not even worth doing that. I'm let's go look at like, a Go implementation of Paxos and see if that's like super maintainable by someone, right? Is it good code? Is it maintainable code? I think that the good, it's complicated, but there is certainly a degree of subjectivity to it. But that's actually that's part of the thing too, right? Like I think it is worth thinking about. It is personal. It is subjective. So is a given code base maintainable in the hands of one team, but you swap out different people or a different team dynamic and it's not maintainable anymore?
I think if you're using Go, it's a bit more so than it would be otherwise. And I'm speaking like completely from my own experience here, because Go was sort of designed with that in mind, right? It was designed with the ability, our linters, right? They all follow a similar approach. Our Go font, right? To remove, everybody's pet peeves around formatting. I want my braces on this line. I want mine on my, these kinds of things, right? So our entire sort of ecosystem like prides itself on the ability of anyone finding a Go code base. You might not understand the problem domain that you're reading about, but you will read you could read the Go code, and the code itself will be readable to you, right? As somebody who's completely new to that code base, right? And since you're going through a 250,000 line code base right now, you can attest to that probably, right? So to me, that's the thing. Like the technology that we use can help, right, in the maintainability, right, of software, right? So if we add that sort of lens to it, I think the technology plays a huge role in that as well, not just the people.
And I think in that case too, we have to like maybe level up what maintainability means as well, because it's like, okay, well, if we want to be able to move this code base between teams, say, like if we have, say, microservices, and those microservices might be, handed off the different teams to reorg to like make it like make things make more sense. I think that's where you have to start building more, I guess, documentation in this case, or just processes and practices into your organization that allows that code to be moved between. And that inability for a code base to move from one team to another team becomes a problem of maintenance, right? It's like, okay, now this code base that might be maintainable for one team is now classified as unmaintainable because it can't be maintained by 2 teams or 3 teams or however many teams that you want it to be maintained by. And then that's a thing you have to go back in and resolve. And I wonder if that helps us frame maintenance as well, to kind of like help us answer this various question that exists right now of like, what is maintenance? Maybe it is this thing of like, a sense of the team. So it's like a subjective thing and like a comparator over time. So it's like, all right, well, this code base is currently maintainable because like we can do something that we weren't able to do before. Now we can do it now, and we continue to sustain the ability to do that into the future. If we add a new thing to our definition of maintenance, then something that was maintainable becomes unmaintainable, and we have to like bring it back to home of maintenance. It reminds me a lot of simplicity, right? Like what is, simple, and the famous Rich Hickey talk of simple made easy and all of that. It's like, it's this very difficult concept to like pin down, grab down, and it when you go into a code base, right? A simple code base when you're in it and you're working in it. And it's hard to figure out when you've lost that simplicity, but you always sense that you've lost it. I feel like maintenance is the same thing. It's like, when you're in a maintainable code base, it has a certain feeling. And then when you've lost that, when something has diverged, and it's like, okay, this no longer feels like a maintainable code base anymore. There's something wrong with the way that we can properly maintain it.
I feel like this is all subjective, though. I mean, this is all very much our own experiences, and I think naturally, as an engineer grows from junior, intermediate, senior, super duper senior, whatever other titles we throw out these days, staff, and whatever.
I prefer superist senior. Thank you very much.
Yep. Right. It's all. I mean, you get that gut feeling that Chris is talking about, right? It's like, yes, this is based on my experience, based on what I've been through. This feels good. And when you start to lose that grip on and when you can no longer hold in your head, all the different strands that you've had to pull to understand one single feature in the code base, once you've lost that, then you kind of this could be better, right? But is there a more scientific method, right? Like I remember back in my Ruby days, we relied quite a bit on things like code climate and whatnot to measure things like cyclomatic complexity and sort of repetition, all these kinds of things, like some heuristics, and trying to figure out, okay, based on a common set of agreed upon don't do's, right? And in this case, the Ruby community, right? These are the things you should avoid doing in your code base. So you get that feedback almost immediately, right? You open up a PR and then boom, you've got some feedback from a machine, right? Not from another human, from a machine telling you, hey, some linters, and this is what we found. Rubocop yelling at you. I mean, I remember, I'd be fighting Rubocop every day on every MPR because I'd be like, oh, okay, fine, I have to go and fix that, right? Oh, okay, fine. Like basically, but you're paying that cost, and you have a machine helping you, right, to identify these things, and all in the hope that you will not get to a point where you've got so many of these, the accumulation of these minor paper cuts, right? We call them, that the code base becomes sort of every time you're in there, it's kind of feels yucky, kind of feels that feeling that you're talking about, Chris. Like it's like, oh man, we have too many, little pinpricks here, kind of thing. Is there such a thing? And go up? Obviously, we have our linters. We can have that sort of immediate feedback mechanism, but do we all agree on patterns and best practices and things, the stuff that we sort of usually throw the word idiomatic go at, right? Like, is that our common set of patterns? Is that as scientific as we get?
I feel like for Go we could probably get at least part of the way there. Like once again, I'm always thinking about writing because I'm a writer. I'm kind of thinking of like manuals of style, and how when you have a manual style, it has a lot of very strong opinions about this is how you do things. Exactly.
Yeah.
Exactly. And
For those wondering what we're laughing about, Sam just pulled up a book on style.
yeah, it's Drunken White.
The
It's a
book on
classic.
style, in fact,
The book,
yes.
yep. The book. Yep.
Indeed.
Chicago Manual of Style sitting on my bookshelf right over there.
Oh, it's a fight.
That's
It's
a
a fight. Yeah. Writer's version of tabs versus spaces. Yeah.
Yep.
Yeah, exactly. It's like the famous, like, you know, you have closing quotation marks. Does the comma go inside or outside of that?
Mhm.
Right? Like there are these things
Outside.
there are these things that are like I don't think there is an objective answer, but we still need an answer. So I think like if we as a community or if we as a group of people can craft something like that, then I think the answer to your question is like yes. I feel like there is a more scientific approach we can take to things. But I think for us, especially, you know, if we take kind of wider angle of it, not just Go, I don't think so. Because I'm thinking, I think a lot about like, you know, once again, writing. It's like what's good in a romance novel or like one of those trashy, you know, airport romance novels versus what's good in the New York Times is going to be very different. And neither is wrong. But like, and you probably wouldn't want to label either one as wrong. And I feel like code is the same way, right? What is good in Go is not the same as what is good in Java. And I think even within Go code bases, what's good in some Go code bases is probably not good in others. Like I think of the use of the unsafe package or the use of the sync package. Like some teams and some organizations, that's a good decision. That's a good thing to use. It's like you have the engineers with the experience. Other teams probably shouldn't be doing that. Like someone's gonna like blow off their foot with that. Man, gruesome analogies today.
Seriously, it's just. I mean, and also I don't know about you, but I start every main package with a compare and swap because that's just how I roll. Like,
why use mutexes when you can use atomics? Like, come on.
Seriously, it's all the cool kids are doing.
I think it's like one of those things that like if you define enough components of it, though, you can get toward a more objective thing. But I think it will always have hefty amounts of subjectivity that you need to kind of abide by. And I think we as a Go community, I think this is like a thing that we need to do is we need to start writing these things down more, right? You know, when you look at the Chicago Manual Style or the AP style book, like they didn't just appear as 1,000-page. Well, the AP Manual Style is shorter, but they didn't just appear as these like huge books. They
important parts
appeared over time. Okay, I have problems
style,
with
the good parts.
We are not.
85 pages. What is this 1,000-page business you're talking about?
There are some antiquated things in that book. Anyway.
Yes, there are.
They didn't just spring out of like, you know, out of nothing. They were developed by like smaller manual or smaller style sheets for specific books over time and then compounded over time. So it's like, I think we as a community need to start just doing that action of like more people writing manuals of style. And there's some out there, right? You go, I think Uber has one for Go. I think Facebook has one for Go. You can go look, you find them. But they're all very, very, very short, not even 85 pages, right? These are like, you know, 5 pages. And I think that's what makes it so hard to understand what maintainability is at the end of the day. Because, you know, once again, to go back to the paper cuts, those small paper cuts are those small little decisions that, you know, aren't being aligned over time. It's the equivalent of like not making a decision about whether the comma goes inside or outside the quotes. And then it's like different for every paragraph in the whole book. And it's like, pick a way to do it and then stick with it. It's one of the reasons we love GoFumped. It's like brackets go here. Like these things go in these places and that's where they live. And now we don't have to think about it. We don't have to care about these things. So I just think, yeah, that was a very, very long way of answering your question. I hope I actually like captured some of it.
Can I try to sum that up into a pseudo-scientific, still subjective, but something that has more numbery bits in it?
Go for it.
I want to loop back on the correctness bit that we were talking about earlier. I mean, everything you were talking about just now are essentially correctness criteria. Not formal verification correctness, but like it's correct if it passes linting and not if it doesn't. I would offer that the maintainability of a code base, starting just accepting the premise, this is subjective because I don't see any way around it, is the ratio. You can understand the maintainability of a code base by looking at the ratio of time spent researching what is correct versus making the thing correct. Whether you're talking about trying to fix a bug, and so, failure locality, right? Like, how long does it take to figure out why the thing is failing? How long does it take to figure out the rule you should apply in deciding how to fix the thing versus actually fixing the thing? That ratio, which, yes, like, will vary from person to person based on the length of their experience, their familiarity with the code base. But again, I don't see a way around it. I think that may be the kind of core of what we're driving at here.
Yeah. I feel like that sums up what I took like 10 minutes to say. Okay, so speaking about Go, because we're kind of getting toward the end of the episode here, and I feel like we've been very light on the Go content in this episode. So it's Go time. Gotta talk.
No, I think it's been implicit in there. I think it very much applies.
Ah, well, thank you for saving me there. But is there anything that I guess any of you would give as what makes Go a good language for building like maintainable code bases? Like what things do we have that are like, yes, this is why I like and enjoy writing maintainable code, for knowing that we haven't quite defined maintainability that well, but this is what I like that Go has that makes it so I can write maintainable code. And then what are some things, if there are any, that make Go a bad language for said maintainability? If you each want to answer that in turn.
I already gave my reasoning for that. The fact that I can drop a new person in a Go code base, and even though they're still learning about the problem domain, it's not Go they have a problem. They're not fighting the language. It's not Go they have a problem understanding. It's what is this type doing? Where is it used? Why is it? What business problem is it solving? Right. So that, for me, I've never experienced a language that gives me that sort of room, right, with my engineering team to be able to say, hey, go into this code. I know you've never worked in this code base, but this is what it's supposed to do, right? I have a bug fix, or I have a feature. Drop in there, see what you can do. And sure enough, and relatively speaking to other languages, they come back much more quickly with the fix or the feature or whatever it is, because they didn't have to fight the language, right? They easily understood what they were reading. Once they understood the problem domain, they were able to execute and get the job done. There's nothing like Go that does this, in my experience.
Ian.
Yeah, so I mean, I'll mirror that the simplicity of the language just adds to maintainability. But on top of that, I think the errors as values really adds to this, being able to explicitly see error paths and not worrying about exceptions and trying to trace these all the way back up. Really adds to like glanceability and therefore maintainability.
Wait, so you don't use panic, defer, recover everywhere in your code all over the place all the time? That's crazy. I thought that's what we all did.
Sam's best practice.
Shit. I got to go rewrite a lot of code right now, guys. It's not good.
Panic-driven development.
Sam.
Yeah. I mean, I'll go with the definition I just offered, right? Like, I think that I will mirror these same statements and translate them into the ability to quickly, to with very little research time and mostly fixed time, hone in on the basic answers to the questions about structure of code. I mean, I remember running face first into a very large Ruby code base and being gobsmacked about my inability to figure out what felt like basic questions. I had been really just focusing on Go code for a while and came back and I was just like, wow, I can't even just like look up symbol names and find them in places. There has to be like, special pseudo static analysis tools to do this for me. And I just about lost my mind. So yeah, the manner in which the structures, invariants, rules, whatever the language, make it possible to, even over large code bases, have clear answers to questions about basic things like what are all the instances of this, references to this type, or to this interface, or perhaps even find all the implementations of it, a relatively difficult thing to do and yet still very doable. Like Go is very enumerable. It's very analyzable. And that means that most of my cognitive effort is spent on dealing with the higher order abstractions that people have tried to create, because all the boring questions are quickly answerable. And so I can get right to the heart of the matter.
All right. And then final question. What would you add, if you have anything, to make Go more, does not make Go itself more maintainable, but make the code that we write more maintainable?
Generics. Hell no.
No. I want generics, but just for me. It's everybody else can screw themselves, right? Like, because then I know what mine do, and I don't have to deal with any of your garbage, and then we're fine, right? I'm fine. That's what's important here. Yeah.
I see thinking faces. So I'm like,
Oh, I would add Rust. That's what I would add. I would really like to have, compile time. There you go. I would really like to have
that's the next
compile
segment.
time guarantees about shared access to global immutable state. Forget this Go test race garbage. Come on.
Yeah.
Static or nothing. That's my. Is this a helpful answer? This isn't a helpful answer. I'm sorry.
Oh, man.
Well, we avoided dependency management, so it's okay.
We did. Scooted right by it. Well done.
Okay.
Nice.
It's time for unpopular opinions, though. So let's see if the soundboard's working now.
I actually think you should probably leave.
It worked.
Huzzah! I figured out how the soundboard works. All right. Ian, you're up first. Unpopular opinion.
I really don't have one this time. I cannot think of anything.
Oh, man. It's okay. Sam has an extra 4 for you.
Oh, crap.
Let me hear some other ones, and I'll if something pops in
Get the
mind.
wheels turning.
Sam, any unpopular opinions?
I totally had 2 at the beginning, and then we were talking about all this interesting stuff. Don't. Well, I was going to say don't use gRPC, but I can't actually back that one up.
You don't have to.
Unpopular.
You don't have to back it up. You can just throw it out there.
Oh, I can just throw it out there. Jeez, God, that's liberating. Okay, don't use gRPC.
No,
but that's their problem. All right, don't use gRPC streams. Unpopular.
Ooh,
There we
okay.
go. Ooh.
That's nuanced. Yeah.
I feel like that's not unpopular though. Like GRP.
Right, that's the problem. Is that all of my opinions are right and popular, and so how am I supposed?
There's the unpopular opinion.
There it is.
There it is. There we go. There we go. There we go. Yeah.
Oh,
Yeah.
man.
And yet I also think that one might be a relatively common one, even if not necessarily unpopular in our industry. We've done enough meta dancing. I feel like Johnny gets to go, and then maybe I'll have something more real in a minute.
Johnny, I know you have many
Yeah.
unpopular opinions. So
I think let me formalize it into an actual unpopular opinion. I don't think you should have separate teams, feature teams, health squads, folks who only work, on greenfield stuff or whatever. And I don't believe in sort of, because what if I was hired and I was put on the bug squash team, and then I want to work on some feature stuff. Like, why am I never gonna get a chance to do that? Right? No, I think teams should be loose in terms of their memberships, and people can just, if you want to have formalized rotation, to put people in different teams, and that goes for on call as well. Right? I firmly believe that if you're on a team writing software that goes into production and it needs to be operated, right? I think you need to be on the hook for when something goes wrong. You're in the pager, you get called as a responder, right? I think that perhaps that is another opinion, but I think you need to be part of that rotation as well. So the whole and it all basically falls under this umbrella that as an engineer, you need to be exposed to all the layers, right, of the stack as it pertains to running the piece of software that helps a business make money. I think you need to understand each, maybe even spend some time in support, right? Be at the front lines of customer requests and bug filings or whatever it is, right? So play a role in each layer of that. And trust me, this is not a punishment. This is going to make you that exponentially better engineer if you understand the different vectors, right, of things that are coming at your piece of software that you're writing, that your team's responsible for. That's going to make you like, that's going to give you superpowers as an engineer. That's all I can say.
I think I agree with that. Not the on-call stuff, because I don't wake up for anything when I'm asleep. So like things is gonna be broken until I wake up in the morning. So if that's okay, then sure. But like I feel like maybe on-call should be for.
You wouldn't do well on my team.
No. This is also why I purposefully avoid roles that have on-call components to them, because I know this about myself. So I don't.
It's good to know thyself.
Yes.
Man who understands his constraints. I mean, respect, right? Like it's yeah.
I'm also one of those people that like I like high level stuff. I like being at 30,000 feet. I can come down to the ground at some point, but like, and on calls usually not at 30,000 feet.
That's for the birds.
a little bit lower. But no, I think you're right though. I mean, I've been doing a bunch of security engineering related work at work, and I'm like, more people need to understand security, not to implement it themselves. Please don't go roll your own crypto. But I think from like actually getting in and understanding how, public key infrastructure, how certs work, how public-private key pairs work, how like cryptography in general works. Like, I think enough people don't get exposed to that because security is like in this specialized area. I think reliability is the same sort of thing where it's like, there's the SRE team. They tackle stuff. So I am in general agreement with you. I think software engineers need to be taking more on as far as like what their remit is. It shouldn't just be go build some products, go write some code.
Chris is like, I agree, except when it applies to me.
I can agree with something in general and know that it wouldn't work that well for me. I mean, like, I could do on-call just during the day hours, like, or more so, I just will write software that doesn't crash at night. So
Ooh, okay.
Or doesn't crash at all. There's the.
Ooh,
see, that's the
or
trick.
only crashes only software, which is a real thing. That's a great thing. Ian, I do have one. If you want another minute to think, otherwise go.
You can go ahead.
Do not use semantic versioning for any versioning system that you create unless you can define what backwards compatibility means clearly and precisely.
Mm-hmm.
Yeah,
that is layered.
Skating into dependency management, just a little.
Yeah.
A little subtweet there, but yeah.
Yeah. Like
sneaking in. Yeah.
Snuck that one in.
Just yeah.
I got you.
I mean, I don't know if that's gonna be. It'll be popular among some people and very unpopular among other people. So.
The conditionality makes it very interesting.
Yes, indeed.
If I've had previous conversations with you about it, you know that there's a deep troll in that statement too. But I'm not gonna unroll it here.
I was gonna say, depending on how there's gonna be a whole swath of new Go developers who have no idea of the backstory for all this. But there's gonna be a bunch of people who are like, yeah, I get what you mean.
We get
I think it's a statement that stands on its own, though, independent of any history. So
Right.
yeah. There's a lot there to that one.
I think it hooks into like the episode. We started out just talking about maintenance, and we're like, maybe we should define what maintenance is. So if there's a specific thing that's at the crux, I feel like when it comes to semantic versioning, the thing at the crux of it is this idea of backwards compatibility, because like that's what all of the digits in it are about. Is like how much have you maintained backwards compatibility? If you don't define what that means, well,
you kind of have a problem.
You wind up talking and you wind up with that function that is like means different things to the different people, and then it has 14 parameters. They still don't describe the entire possible space. I've never had
thus far. We've been talking mostly about maintenance as though it's something which is kind of confined to a single team, which kind of isn't true. When you've got a blast radius that is as large as your depender space.
This is why this is a series and not an episode. But I've never ever run into a code base that I've maintained that has a 14 parameter function that only has 3 lines of code. I've never felt that situation.
Not even one time.
Never have I ever.
The thing about it is, in that situation too, that code is like, this is actually correct for the state of the code base right now, and I'm mad about it. Yeah, just one 14 parameter function calling another 14 parameter function.
Well, I would hope it's at least like a 14 calling a 13, so you're doing like partial function application all the way down. You're just peeling parameters off like one at a time. Does it not do that? Now I'm picturing like a code pyramid.
It was an unpleasant situation when I had to refactor a lot of code to get rid of that. And I looked at it and I'm like, this looks wrong, but it's not wrong. All right, merge it. It was a bad situation. Anyway, Ian, unpopular opinion. Got anything? It doesn't have to be related to Go or
It
code.
is not related, but I do have something. I do not think variables belong in paths of URLs, like especially in APIs. I think we have query parameters that are built for this, and so all these APIs that are /1 to get something, I think that was a misstep.
You're old school, huh?
When I started, REST was already a thing. I think it was just a bad thing, like
clean URLs. Great idea for WordPress, bad idea for APIs.
Yes.
I feel like I went to.
I feel like
I went to Drupal days for sure. Hearing that, yeah.
I feel like Roy Fielding would be very happy with you right now. I think he has a couple of rants about that. About just your URLs are opaque. Stop putting stuff in them that you need to parse. There's other parts of the protocol. But anyway, yes, all good unpopular opinions.
So we think. Sometimes they end up being popular. Anyways.
I'm not really sure how many of these are going to wind up being popular. I feel like it could be. It's like an actual. Like I'm wondering what the poll results will say. Because we do go and we poll all of these on Twitter, so it should be good.
I mean, my Summer one really, like, that one gets unpopular when you start suggesting alternatives. It sounds fine when you're just like, the world's terrible, don't do that thing, and everyone agrees. And then you like try to suggest an alternative, and everybody's like, go fuck yourself. And so it's depends on how far you walk it out, I guess.
I'm gonna fall over.
We haven't had a bleep on the show in a while, so this is
sorry. I realized I should have inquired at the beginning.
Oh, I mean, Peter got his one swear, so I feel like you also can get a couple swears in.
Okay, all right.
Okay, we're a mostly family friendly show.
Gotcha. Noted. I'll remember for next time. Yeah.
All right, I'm just gonna do the closeout and play the thing, the ending outro. So, thank you, Ian and Sam, for joining us today, and thank you, Johnny, for being my co-host through this, and thank you to all the listeners out there for enduring through another episode about maintenance. There are more to come. do have to say I love our music. Like, I
It
love
is
the Go
pretty
Time
cool.
music. It's except the unpopular opinion song. Who wrote that? Some Matt dude. I'm like, oh.
It started off. I was like, "What am I hearing
What am I
right now?
hearing?
What
Right.
is this?" Yeah,
Yep. I do have to drop, gents. This was fun
it was.
and filled with great wisdom from all around.
Yes. You can stop your recordings as well if you were doing a local recording. And I'm going to pull us off the YouTube. So bye, YouTube.